In this video, we are going to solve the impossible integral. Yeah, this integral is actually impossible if you try to do it in the way it is given. So basically, we just have to try to change the limits, the order of limits, the order of integration. Uh, if we change it into dx dy form, then it's possible, but in the way it is, it might be impossible. Okay, so basically, what we want to do is we want to change the first integral in the form in dx world and second in the dy world. So for that, we first notice that this integral in the x world it's going from 0 to 3, and in the y world it's going from x squared to 9. So basically, this is x world and this is y world. In the y world, it's going from x squared to 9. Yeah. So for all the x values, our x square graph is like this. X square graph is like this. Yeah. So let's say we have here 9, because since it's the y equals to x square graph, so corresponding to 3, we need to have here 9. Okay, x goes from 0 to 3 and y goes from x squared to 9. So y is basically going from x squared to 9. Yeah, so actually this is the area that the limits of integration are showing. Okay, so limits of integration are like representing this area. We don't need to consider this over here. It's just the height, if we need to compare the volume for this figure. Okay, so it's just the height of the figure that's lying on this base. Okay, so basically base is like this. So if we want to change the limits of integration, now we first need to fix the values y is going from. So y is going from 0 to 9, and when y goes from 0 to 9, x goes from 0 to root of y. Yeah, so this is just for x value. This is also x equals to root of y. Yeah, and x is going from 0 to root of y, 0 to root of y. So our height for the figure is there, and now we have changed it to dx dy. Yeah, dy goes from 0 to 9 and dx goes from 0 to root y. So with this manipulation we will be able to solve this integral. Now let's try the integral. Uh, Integral from 0 to 9 in the y world, 0 to root y in the x world, and the integral is x cube e to the power y cube and dx, so sorry, e to the power y cube dx dy. So previously it was impossible because we were in the y world and we had to evaluate e to the power y cube. Yeah, and so we don't have a different like for e to the power y square we do have RCM, but for e to the power y cube we don't have any such functions too. So it's literally impossible. Okay, so but here we don't need to deal with e to the power y cube first. Yeah, we need to deal with x cube since we are in x world. Yeah, so our e to the power y cube will be just constant, and we will have x to the power 4 by 4 as our integral from 0 to root y dy. Now 1 by 4 is constant and can be taken out. Integral from 0 to 9 e to the power y cube times this is y square dy. Now we see that we have 1 by 4 integral from 0 to 9 e to the power y cube, and here if we want to make 3y square, we also need to divide by 3, and 3y square will be derivative of y cube, so we will have a dy cube as 3y square dy over 3. So now you see that it's quite easy to integrate now. 1 by 12 and this will be just e to the power y cube, since d is in the form of y cube, from 0 to 9. So that's 1 by 12, and when y equals 9, we have e to the power 729, and when y equals to 0, this is 1. So our answer is 1 by 12 e to the power 729 minus 1, and we have solved the virtually impossible double integral. I hope you enjoyed the video. I hope you understood the concepts. Thanks for watching. Do keep with us in the next videos too. Hope to see you in the next video. Thanks for watching.